Problem 24 says Mary drew the two-dimensional figures below. Here are the four shapes she drew. I can see all of them. It says which statement about the figures Mary drew appears to be true. Again, something that will help you out on problems like this if they ask you which one's true or not true or false or whatever they might say. Next to my answer choices, put a true and false. The great thing about using this is that even if they ask you which one is not true, there will always be one answer choice that is different than the others. So there will always be one answer choice that's true or one answer choice that's false. Whichever one is different from all the others, that's the one you pick. So let's take a look at these figures and see which ones are true. F. They are all trapezoids. Okay. Trapezoids aren't too tough. Trapezoids need to do two things. Trapezoids have four sides. That's the first thing I'm going to check. Do all of my shapes have four sides? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, they all have four sides. The second thing a trapezoid needs to do is a trapezoid can only have one pair of parallel sides. Only one. If it has more than one, not a trapezoid. So that's what I'm going to do. I'm going to go ahead. I'm going to check now for which of these shapes have one or more than one pair of parallel sides. The first shape has one pair. These two here. If I stretch them out, never ever touch. It doesn't have two though, because if I stretch these sides out, I see that they're going to run into each other over here. So this is a trapezoid. Check the second shape now. Okay. Here. Here. Nope. They run into each other. Let's check the other sides. Now for this part, when I extend my lines, if you do it just with your hand, that's fine. But if you have a ruler, it makes it a lot simpler, and it makes sure that you can keep your lines straight. Oh, run into each other over there. So this second one doesn't have any parallel sides. So the first shape, yes, trapezoid. Second shape, no. So this is false. The trapezoid has to have four sides, has to have one pair of parallel sides. Can't have more, but it has to have the one. G. None of the figures have parallel sides. Well, I just figured out that was false because I know this first shape absolutely has parallel sides. H. They have a combined total of 7 right angles. Okay. I need to check this. Remember, the acute angles means the angles are too small for my sticky note. Obtuse angles means they're too big for my sticky note. But if they're right angles, my sticky note will fit perfectly. Just like that one. Sticky note fits perfectly there. So that's a right angle. Fits perfectly there too. There's another right angle. That one is too big. That's an obtuse angle. This one is too small. That's an acute angle. Now I can't stop by just checking the first shape. I have to check all of them because they said they have a combined total. This one, no, that's an acute angle. When I tried to make it fit, it almost fits. It's very close, but no, this one's too big. This one, that fits perfectly. This one, acute, too small. Okay, that's perfect. It's a right angle. This one's perfect. Another right angle. This one's perfect. Another right angle. And another perfect right angle. Okay, Bella, can you use your microphone? Oh, okay, then you're okay. Got an obtuse angle. Another big one. This one's an acute angle. It's too small for my sticky note. Got another obtuse angle. Too big. And another one that's too. So let's see if answer choice H is true. They said a combined total of 7. Let's count all the right angles. 1, 2, 3, 4, 5, 6, 7. 7. That one is true. Answer choice J says none of the figures have acute angles, but there's acute angles in almost every single one of these figures, except for figure 3. So that's false. And again, if I take a look at that, only one of these answer choices is different. All of them are false except for H. H is the answer that I should have. $25 is a fun one. It's another one that we had a few mistakes on. 25 says which figure appears to have exactly. Well, if you can't see Bella, then go ahead, leave the call and come back in. Which figure appears to have exactly 2 lines of symmetry? Remember, symmetry means that if I were to fold the shape or cut the shape, I would end up with 2 equal halves. So the 2 pieces, the 2 sides would be equal, the same size and the same shape. Figure A has 1 line of symmetry going along this way. Again, if I'm not sure, if I'm thinking to myself, well, do I really know that they're equal? Are they the same? Take your fingers, put them on either side, start tracing your shape. If your fingers are doing the same thing, then you know Same. If one finger is moving for longer than the other or moving in a different direction, you know it's not. Hold on. I messed up that line of symmetry. I actually put it down a little bit too. You want it to look correct. What's up, JD? I did it again.
Didn't you say, like, for symmetry, like, that doesn't it mean congruent?
Yep. For symmetry, when you end up with those two parts, they should be congruent. The same size, the same shape.
And also, didn't you say that you could use your fingers and trace it?
Yep, exactly. If I put my fingers, either pinky fingers because they're smaller, or pointer fingers, whichever, on either side of my line and trace the lines, my fingers, if you look, are doing the exact same thing at the exact same time. Almost like they're in a mirror. They're moving the same way. If one of my fingers starts to move in a different way, then I know that, oh, these aren't congruent. Different. Yes, Jaylene.
Oh, I didn't really understand this one.
Okay. So symmetry, like I said, all it means is that there's an imaginary line that we could make on these shapes. When you make that line, I could either use it as a way to fold or cut, and both sides would be equal. They'd be congruent, same size and the same shape. So with this line, you see here, if I were to take some scissors and cut my shape into two parts, I would have two equal parts. Almost like if it was a mirror right here. You see how they would match, Jaylene?
Yes.
So that means that this is a line of symmetry. Now, for this shape, I can make that line of symmetry and it works completely fine. But if I try to make another line of symmetry, let's say one going this way, it wouldn't work. You see how the top would be the same, but when I get to the sides, look what happens. You see how it's got this part cut out and the other side doesn't? So that means that this can't be a line of symmetry because this side and this side wouldn't match up. They wouldn't be the same. Okay, Bella, ask someone there at the school to see if they could help you with your computer. So this shape here has one line of symmetry. It's only got one way that I could fold it or cut it and get the right, well, not the right shape, but get the same shape on both sides. If I try with answer B, answer choice B, I could make a line right here. And you see how, again, both of my sides are the same? If it was a mirror, and if I were to fold my shape, they would match. And answer B also has another line of symmetry. If I go this way. If I go this way, again, both sides are the same. I could take my fingers, I could trace this, and both of my fingers are doing the same thing at the same time. So this has two lines of symmetry. Answer choice C looks a little bit different, but it also has lines of symmetry. It actually has quite a few. If I draw a line this way, that is a line of symmetry. If I draw a line this way. That's another line of symmetry.
No, I don't need to.
If I draw it this way, there's another line of symmetry. I can draw another line of symmetry this way. And that way. Yep, Bella, I can. So this shape here has a lot of different lines of symmetry.
Yes.
This one has 5 lines of symmetry. Answer choice D. If I look at it, I could try to find one. I'd get close. But answer choice D doesn't even have one line of symmetry. The reason why is because if I look at these parts here, the ones that are sticking out, it's not the same on both sides. I can see that one side bigger than the other. Because one side is bigger than the other, there's no way I can make it symmetrical. It won't match if I try to fold them, because one side will always be bigger. So answer choice D has no lines of symmetry. Nothing. There's not a single line I could draw on this shape that would make it equal and even on both sides. If I go back and look at my question, it says, if I look back at my question, it says which figure appears to have exactly 2 lines of symmetry. That means it has to have 2, not 1, not 3, 2. This has 1 line of symmetry. This has 5 lines of symmetry. This has 0 lines of symmetry. The only one that has 2, B. That is the only answer choice that has 2 lines of symmetry. Not more, not less. Okay, good. 2 more problems that we want to go over because a lot of us had some issues with them. Let's go ahead and go to the next one.